Okay, so I did number 9 in the first web assign, and it said that an inquisitive physics student and mountain climber climbs a 52-meter high cliff that overhangs a calm pool of water. He throws 2 stones vertically downward, 1 second apart, and observes that they cause a single splash. The first stone has an initial velocity of 1.94 meters per second. So let's just draw a picture real quick. There's cliff, person at the top, and there's water, and we'll just call the upward direction positive. So let's just list all of our givens and the stuff that we know. So we are given that the initial velocity of the first stone is equal to 1.94 meters per second. And then the acceleration, since it's going downward, it would be 9.8 meters per second squared. Delta y, which would be the displacement, would be 52 meters, since it's 52 meters up high. And that's it for our givens. So the first part read that, how long after the release of the first stone do the 2 stones hit the water? So it's just asking us for the time of the first stone. So we would just use the equation delta y is equal to the initial velocity times time plus 1/2 the acceleration times time squared. And plug in everything that we know, 52 meters is equal to 1.94 meters per second times time, which we don't know, 1/2 times 9.8 for the acceleration times time squared. And then so it's going to be a quadratic, so we have to clean up everything and then bring everything to one side. So after we do that, we get 4.9 t squared plus 1.94 t minus 52 is equal to 0. And since it's a quadratic, we would get 2 answers, and one of them is going to be negative and the other one will be positive. And since we're talking about time, we would have to take the positive answer because time can't be negative, so we would get that the time is equal to 3.05 seconds. And so since we have the time of the original one, we can actually find the time of the second one. Since in the question it said that it was released 1 second afterwards, we can say that 3.05 minus 1 second would be 2.05, and that would be the time for the second stone because it was released at 1 second afterwards. And this is where some students tend to make mistakes, is that they won't find the time of the second one and they'll just use this time for the rest of the problem. And even though you can't, because it says in the problem that they're 1 second apart, so they would have different times. So just be careful. The time is the tricky part, I'd say, in this question. So the second part read that what initial velocity must the second stone have if the 2 stones are to hit the water simultaneously? So we would just use the same equation we used for the first part. Delta y is equal to the initial velocity times time plus 1/2 the acceleration times time squared. Then plug in everything that we know, and then so that 52 meters is equal to the initial velocity of the second one. And this is another place where students tend to make mistakes with the time, is that so we need a time for the second stone, since we're trying to find the initial velocity of the second stone. So we would need this time up here that we found earlier from subtracting 1 from the first time. And some mistakes that students make is that they just use the first time because they don't realize that they're different times. So we have to remember to use the right numbers. So 2.05 seconds plus 1/2 9.8 times 2.05 squared. And solving all this out, we get that the initial velocity of the second stone is equal to 15.1 meters per second. And that would be downwards. So he's throwing it downwards. And this answer makes sense because it makes sense that the initial velocity of the second stone was faster than the initial velocity of the first stone, because since they were thrown at different times and they hit the bottom simultaneously, the second one would have to have a faster initial velocity in order to catch up to the first one. So, and the last part says, what is the speed of each stone at the instant the 2 stones hit the water? So it's basically asking us to find the final velocity of each stone. So I would just break it up into 2 parts. So we can just do the first part, the first stone first, We can use the equation final velocity is equal to the initial velocity plus acceleration times time, and plugging in everything that we know. And this is another mistake that some kids make, is that they don't plug in the right numbers for this time. Since we're looking for the first stone, this would be the first stone, we need the initial velocity for the first stone and then the time for the first stone. So make sure that we're plugging in the correct numbers for these. So the initial velocity of the first stone that was given to us, we got 1.94 meters per second, and then we know the acceleration is 9.8 since it's going downwards. And then the time for the first stone, we found that in the first part, that was 3.05 seconds, so we plug that in for that. And solving all this out, we get that the final velocity of the first stone was 31.9 meters per second, and that was in the downwards direction. So now we can do the second part, which would be the second stone. So just write the second stone up here, and remember we would use the same equation up here, and remember to plug in the correct numbers for these. So we would need the initial velocity of the second stone, which we found in the second part here, and we got 15.1 meters per second, and then plus the acceleration is 9.8, and then the time for the second one, which was we found up here, we subtracted 1 from the first time, and we got 2.05 seconds. So solving all this out, we get that the final velocity of the second stone would be 35.4 meters per second, and that would be in the downwards direction as well. And these answers make sense too, because the second stone would have a final velocity, like a faster final velocity than the first, because it had a faster initial velocity than the first. So, and they're both acting under 9.8 acceleration, so the second one should have a higher final velocity than the first one, and they hit the bottom at the same time. So the tricky part about this problem was the time. Probably make sure you have the right times, and make sure you're plugging in the correct numbers for everything, because it can get a little tricky, especially in this third part, plugging in the right numbers that you find. So even when you find the correct numbers up here, you might plug in the wrong numbers down here, and you get the wrong final answer down here. So just be careful about that.